Okay, is that clear? I mean, बाकी सब नहीं है क्या? Because there's a power cut, so I don't know how much time I'll be able to continue. But understand my point that this particular question was asked in net examination only. So I'm not giving any question which has not been asked. I'm just trying to say that if at all this question was there. So let's say again, I'm coming back to the question. So question was given 1 upon z ln 1 minus a. So clearly this particular function is of a complex variable. And it was given that this particular function is a function of a complex variable where z was given from r e ki par iota, z is equal to r e ki par iota theta. And theta was given in all possible range. That is from minus theta, minus infinity to plus infinity. Now the question option says that it has a branch point at z equal to 1. That is clearly the truth. Because in any case, logarithmic function has a branch point at z equal to 1. Clearly, you can see. And you can also verify it further also. But right now, I would say that even if you don't want to verify it, you can clearly see that the options suggest you so. So there is a branch point at z equal to 1 in any case. Okay. So there is a branch point at z equal to 1. Otherwise, see, if the options were not there, I would have taken some sort of contour or r equal to r e ki par iota theta. I would have revolved around it. But for now, just understand that it is a branch point at z equal to 1. Clearly, there is a branch point at z equal to 1. Now let us move further and see how does z equal to 0 behave. So at z equal to 0, you can clearly see if I expand ln 1 minus z into some sort of series. So first, the series will be valid in the region mod z less than 1. And secondly, you can only expand ln 1 minus z in the form of a series only when it is analytic. Okay. So it is analytic only in the principal branch. Okay. Because beyond that, the function will encounter a discontinuity. I told you on the very first day that let's say this is yours. If I don't take a principal branch, so if I'm moving from 0 to again 2 pi, for these particular points, you can approach this way. The argument will be initially 0, and after one complete revolution, the argument will be iota 2, 2 pi. So I told you on the very first day that if you take this kind of principal branch, that is theta lying from 0 to 2 pi, you're encountering discontinuity here. So what we did first, we introduced a branch cut and removed this particular axis. So answer to this is, if you really want to, if I have restricted this kind of thetas, if I have restricted this kind of theta, so basically I'm in the principal branch. When I'm in the principal branch, I can write ln1 minus z in form of a power series. This is a power series. And I found that z equal to 0 is a removal singularity for this. Okay. Clearly, you can see that z equal to 0 is a removal singularity. See, because there is no such 1 upon z term. See, there is no 1 upon z term. So there is no principal part term as such. But what happens if you cannot do so? So if you are not in the principal branch, then clearly z equal to 0 is a simple pole, because limit z tends to 0. This gets cancelled. This will give you ln1 minus z. Z tends to 0, ln1. Ln1 will be not in. If it was the case of real, then answer would have been 0. But this is not the case of real. This is case of complex variable. So here I will write 1 in the most general form, that is iota 2 pi. Certainly it is non-zero for all n belongs to natural except for 0. Otherwise, overall it is a non-zero term. Overall it is a non-zero term. So what I can say to the minimum that z equal to 0 is a simple pole in that case. So z equal to 0 is a simple pole if I am talking about, if I'm talking about all branches other than principal branch, because at principal branch you can have the freedom to expand, but otherwise you don't have other branches. So other branch means other than theta lying from 0 to 2 pi. So for other branches, I cannot say, let's say if I'm saying my branches, let's say 4 pi silica 0. So now here you have revolved 1 and again 2. So basically, you have encountered this kind of axis. So here your function is discontinuous. So for all other branches other than the principal branch, z equal to 0 will be a simple pole. But otherwise, for the principal branch, it will be a removal singularity. Yes or no? बात समझ में आई? भरत को समझ में आई? Is that am I audible?
Yes, sir, clear.
Because today I have a power cut, so probably I may not be able to teach you for 3 session. Probably this will be the last session, and that also I don't know how much long it will last. The only point is because I'm on the mobile internet, so probably lag would be there. So in any case, understand my point that only in the principal branch I can say that my z equal to 0 is a removal singularity. Otherwise, I would say that z equal to 0 is a simple pole for all other thetas except the principal branch. Now, what about z equal to infinity? What sort of singularity is z equal to infinity? So let us see. For z equal to infinity, you have to just replace this way. So this will be ln 1 minus 1 upon w, right? And I will get w ln w minus 1 divided by w, and this will give you w ln w minus 1 minus ln w. Okay, so w equal to infinity, clearly you can see that here w equal to infinity, w equal to 0. Clearly you can see that w equal to 0 is a problem here. So w equal to 0 is a problem here. So you can say that, and here it is not a problem as such. So I'll not think about this. I'll think about this only. So I'll say, let us extract this term GW. So GW is nothing but it is equal to W into ln W. Okay. And you can clearly see that W equal to 0 here, it is a branch point. Since W equal to 0 is a branch point, I would say that Z equal to infinity is also branch point. Okay. So clearly two things can be said, Z equal to 1 and Z equal to infinity are branch points. What I can say that Z equal to 0 is a simple pole only for the other branches, not for the principal branch. Not for the principal branch. So for all other branches, Z equal to 0 would be a simple pole. And this was the question that was asked. Okay. Is that clear to you? So should I repeat it all over again? So here is the answer. I think branch point at Z equal to 1 and Z equal to infinity, and a pole at Z equal to 0 other than the principal branch. The answer should be B. Okay. Are you getting my point? ये चीज समझ में आई या नहीं आई? Please let me know.
Right, sir. Right.
अल्पना समझ में आई?
Question.
This was as in my first attempt of NET.
Yes, sir.
When I gave the NET for the very first time, that is in my third semester. This question was there. Okay, so that is why I clearly remember. And for your kind information, I corrected the option number A. Okay, so and I would say that it was only a guesswork. I could assess this thing, but what made me tick A, I don't know. But actually, I made a mistake. I took when I strike मैंने A option को strike किया था, and eventually it led me to 1 more year of giving NET JRF, because if I had done this question right, I would have cleared NET that year itself. So ये मैं कह रहा हूँ कि ये छोटी-छोटी चीजें please do understand. ठीक है, ये चीज समझो. So this is B. ठीक है, okay. So let us move ahead and ठीक है, समझ में आई यहाँ तक बात? I don't think there is an issue about it. Okay, so let us focus our concentration right now on something called as integration. ठीक है, फिर थोड़ा सा उसको भी चालू करते हैं, otherwise we'll be quite delayed in doing so. ठीक है, integrals. And first part, and on the very first day I told you that there may be analogous result to your real analysis, but exactly they don't mean the same. Answer is, let's say if I'm saying I'm talking about of a definite integral in function in real variables. If I'm talking of a definite integral of a function in real variable, that is here x belongs to R. Now here if I write integral a to b fx dx, then what do I mean? I mean some area. Okay. Let's say if that's not the case, I say that my function force is some variable force behaving this way. And I say I have using this kind of variable force which depends on x, I have moved from x equal to a to x equal to b. And if I'm asking a standard 12th child that tell me what is the work done, so he will tell, okay, just give me a minute. He would just take an integral of this particular force from x equal to a to x equal to b, and he would tell me what was the work expended in doing so. Okay, so for example, if I have PdV, if I have pressure, then volume, then somebody would give me the work done, PdV. Okay, in thermodynamic systems. So overall, this was the scenario when it was the definite integral in the one variable case. Here you have something called as line integral. Okay, which certainly does not represent some sort of area, but it has, you can say that what I would do, I would reduce complex integrals into two definite integrals, and let us see how. Before moving there, let us understand a few more things that I would use quite often right now in this integration chapter. Okay, so the one of the things is contours. So time and again, I would use these terms: arcs, contours. What are these? So in most simplest manner, I would write, I mean, probably it may not look simple to you, but let me see. So I would write an arc first. So what is a continuous arc? So I would write, see the continuous arc. Continuous arc is the set of points x comma y, is set of point x comma y, which satisfies certain equation, that is x is equal to phi comma t, y is some psi comma t, and where t lies between a to b, some a to b. And these phi and psi are nothing but continuous functions of t. These are continuous functions of t. So if my curve can be represented, if point on my curve can be represented in some parameters, that is t here, and they are nothing but some continuous function of that parameter, then I would say that my function is my set of all those points constitute a continuous arc. Again, I'm saying, what is a continuous arc? See, if my point on the arc can be represented parametrically in form of two continuous functions, then I would say that my arc is a continuous arc. Yes or no? In fact, if for each point, I will come to the if I will come to the examples also, don't worry about it. If for each point x comma y on the arc, there corresponds a single value of t, that is, if I'll give you t and you say अच्छा t की वैल्यू ली एक ही पॉइंट है उसके लिए x comma y, मतलब ऐसा नहीं है कि t की दो वैल्यूज के लिए एक पॉइंट आ जाए, ठीक है, आई एम सेइंग t की एक यूनिक वैल्यू के लिए एक यूनिक पॉइंट x comma y. In that particular case, I will say this arc is a Jordan arc. Okay, these are just definitions, don't worry about it. So for example, if I say what would be a line in that particular case? Let us understand. Let's say if I'm saying let's say line passing through origin. So all these points can be represented by x comma y, okay? And if it is a line passing through origin, then what will be the functional relationship between y and x? This will be y equal to x, yes or no? So if I write t, x is equal to t, then y equal to t. So instead of writing x comma y, we can represent the points on the line as t comma t, yes or no? And understand my point that t is a linear function and it is a continuous function. T is a linear function. For example, if I'm writing ft is equal to t, what is t? T is a linear function. Linear function is a special case of polynomial function, and polynomial function are in general continuous function. So t comma t, so x is represented by some continuous function, that is t, y is represented by some continuous function, that is t. So these both are represented by some continuous functions or some continuous parameters. So I would say that this particular arc, let's say from a to b, is a Jordan arc. Let's say here 0 to b or 0 to a if you take, not a to b. So this will be a Jordan arc, yes or no? So straight line would be a Jordan arc. Yes or no? Anybody has any issues? कोई बच्चा को बोलो तो सही, क्या हो गया? What happened?
Yes, sir,
नहीं
clear.
हैं?
नहीं, इश्यूज तो नहीं है, पर हाँ पहली बार है इसलिए.
अच्छा अच्छा, ठीक है, वो कोई बात नहीं. मुझे लगा कि ओके, कोई बात नहीं, आ जाएगा धीरे धीरे से. So I thought that he was responding to this sort of.
नहीं ओके नो है.
ठीक है, so this is not that है. ठीक है, so Jordan arc क्या होता है? Jordan arc is some arc where all the points can be represented in terms of parameters and those parameters are continuous functions. So I hope I am समझ में आ रहा होगा यहाँ तक, ठीक है. एक छोटा सा टॉपिक समझो, लेंथ ऑफ आर्क. सो व्हाट विल बी लेंथ ऑफ आर्क. सो इसको बहुत आसानी से समझते हैं. ये तुम्हारा कंसेप्ट तुम्हारे मैकेनिक्स में भी बार बार आता है. तो सो फॉर एग्जांपल, इफ आई एम मूविंग अलोंग सम आर्क, ओके, सो इफ आई एम मूविंग अलोंग सम आर्क and if I'm saying what is the length of arc here, so what would you do? You would say, acha, okay, I would do one thing. I would take some ds. So this will be some ds. This is some x and this is some y. So for example, if I'm moving along an arc, so if I'm moving along an arc, let's say this is your s, this is your ds. So you're moving from s plus ds. So this is your ds. So obviously you would have moved some dx and some dy. Yes or no? And infinitesimal small ds would actually behave as if it is a line. It is not an arc. Okay. So if I'm having an infinitesimal small, you can say that differential element of s, that is the arc, you would see that this is not an arc, rather it is just a straight line. So what I can say that my ds ka square would be equals to dx ka square plus dy ka square. Yes or no? And eventually I would write that dx ka square, and let's say x and y are some function of t. X and y are some function of t. X and y are some functions of t. So I would write ds by dt ka square. This will give me dx by dt ka square, and this will give me dy by dt ka square. Let's say if my x and y are some functions of t, so I can write x as some function of t, y as some function of t. So instead of this thing, I've just divided by dx by. So I will write this way. So ds by dt will be equal to what? Root over x dash t plus y dash t. Yes or no? And this square, sorry, my bad. Okay, and eventually I can write ds as root over x dash ka square plus y dash ka square and integral. Okay, let's say if I have to evaluate this length of arc from a to b, so I will go from integration from a to b. This will give me the length of the arc. So length of the arc, most conveniently for all sort of curves that I've been talking right away, abhi jo humne poola, jahan pe x and y can be represented by some continuous function of t, is given by integral a se lekar b. Let's say length of arc in the interval a to b is given by root over, I think this is phi dash t ka whole square plus psi dash t ka whole square and dt. Yes or no? ये बात समझ में आई? This will be length of the arc. Yes or no? बढ़े आगे?
हाँ भैया.
So what is smooth arc for that case? ठीक है, smooth arc का मतलब क्या होगा? Smooth arc का मतलब simply समझ लो कि जहां पर मैं ऐसा कह देता हूं, let's say what is smooth arc? So not only that your function must, not only that your x and y be continuous, but dx by dt and dy by dt also continuous. अगर ऐसा है, so यहां लिख देता हूं, an arc is said to be smooth if, I think, x dash, that is phi dash and psi dash, are also continuous. So if phi dash and psi dash are also continuous, I would say that my arc is smooth. And all those smooth arc, if they form a continuous chain, and if I just join them up, this will form a contour. So I would say, simple language, a contour, and please mind my mistake here, phi dash and psi dash are also continuous, otherwise there will be problem. Are continuous. So while evaluating your length of arc, phi dash and psi dash must also be continuous, because if they are not continuous, then I will not be able to perform this kind of integral. Okay, so so what is a contour? So a contour, I would say, is a what you can say is simply a continuous chain of, I think, some finite number of smooth arcs. ठीक है, because just understand, it's not that कि very बहुत hard and fast ऐसे ही पढ़ना है, but understand ये सब चीजें हम बार बार बोलेंगे, that is why I'm doing it. ठीक है. And what would be a closed contour? So for example, if I'm saying that there exists a point such that phi of that point becomes psi of that point, मतलब ऐसा कुछ हो पा रहा है कि जैसे, मतलब जैसे ऐसा हो पा रहा है कि जैसे मान लेते हैं सिंपल केस में, जैसे सर्कल को क्या आप बोलोगे, सर्कल विल बी अ क्लोज कॉन्टूर. क्यों? क्योंकि इनिशियली phi at 0 and psi at 0 is equal to phi at 2 pi, comma psi at 2. बात समझ में है कि नहीं? So basically point वही है, लेकिन after one complete revolution you come back to the very same point. These are called as closed contours. Closed contour का मतलब ये हो गया, if मैं ऐसा कैसे लिखूं इस चीज को, if it happens that your phi at A becomes phi at B and psi at A becomes psi at B, while saying x and y as some phi t and comma psi t, I would say that I have come back to the same point. आप A पे थे, आप वापस B पे आए, तो आपके जो इनिशियल कोऑर्डिनेट्स हैं वो भी, और जो एब्सिसा है और जो कोऑर्डिनेट्स मतलब जो x कोऑर्डिनेट और y कोऑर्डिनेट, आप you've come back to the very same point. So basically this describes your closed contour. Yes or no? So if I'm saying that my x and y can be represented as phi t and psi t, where phi t and psi t are continuous functions of t, such that phi of a is equal to phi of a is equal to phi of b and psi of a is equal to psi of b, then I would say that I am on a closed contour. Yes or no? यहां तक समझ में आई बात? किसी को नहीं समझ आ रही तो प्लीज पूछ लो. कल्पना को समझ में आई? हेलो, समझ में आया नहीं है बच्चों को?
हाँ भैया, आ गया आई आवाज.
आगे आवाज आ गई, ठीक है.
हाँ.
आई थिंक देयर वाज अ ग्लिच, आई डोंट नो कहां गया ये. जस्ट गिव मी अ मिनट. ठीक है, यहां तक समझ में आया? एक मिनट को, व्हाइट बोर्ड, दिस वाज व्हाइट बोर्ड. जस्ट गिव मी अ मिनट. ठीक है. सो व्हाट आई वाज डूइंग इज, स्क्रीन विजिबल है अभी? आई थिंक देयर वाज अ
हाँ.
इशू विद द इंटरनेट ना. तो यहां तक समझ में आई मेरी बात? अब देखो, भरत समझ में आ रहा है बेटा? ऊपर से तो नहीं गया? बस ऐसे समझ लो, मतलब ऐसा कोई जरूरी नहीं हार्ड एंड फास्ट इसको समझना, बट स्टिल, क्योंकि दीज ऑल आर ऑल द टर्म्स दैट वी आर गोइंग टू यूज नाउ. हाउ वुड यू write a contour integral? The first thing is, how would you write a contour integral in the complex plane? So if you are saying कि contour integral लिखना कैसे है, तो क्या होगा? Let us consider a smooth arc. Let us consider a smooth curve मान लेते हैं. Let us consider a smooth curve. ठीक है. स्मूथ कर्व मतलब वापस बोलूं, स्मूथ कर्व मतलब your x and y can be represented by continuous functions of phi t and psi t. Further, phi dash t and psi dash t are also continuous. बस ये समझो. जैसे कि एग्जांपल बताता हूँ, जैसे कि मैं कहता हूँ arc on the circle. So let's say if I'm saying arc on the circle, will it be a smooth arc? Will it be a smooth arc? So I'm talking of one quadrant of a circle. So one quadrant of circle would require me to move from 0 to pi by 4. At any point on the circle, let's say this is a circle of radius a whose arc is this, I would write it as a cos theta comma a sin theta, isn't it? So this is the parameter. Arc, cosine and sines not are continuous functions of theta. They are indeed. Are you getting my point? So x as a function of theta can be written as a cos theta, y as a function of theta can be written as a sin theta, and both of these are continuous functions of theta. So clearly x and y can be represented in terms of parameter theta, and these are just continuous functions. And what about their derivatives? The derivatives are minus sin theta comma cos theta, again continuous functions. So I would say that my one quadrant of this circle that represents an arc, this is a smooth arc. Yes or no? यहां तक समझ में आई मेरी बात?
Yes, sir.
Okay, and what would I do? I would just simply, let's say this is my point A. I'm just giving an idea. I'm not deriving it exactly, but I'm just giving an idea. Let's say if I'm moving from A to B on this smooth arc C, what would I do? I would simply divide it into different sub-intervals. I would divide it into certain different intervals. Are you getting my point? So don't इसको ऐसे समझो जैसे ये x, ये तो x axis है, y axis. So basically आप क्या कर रहे हो? You're here on some point. Let's say this is your z0, and let us say this is your zn, मतलब final destination, and then you have some sub intervals z1, z sub. I think what should I say not subintervals exactly, but some points, intermediate points. So I have divided this entire smooth curve into some small, you can say, I would say partitions, or not partition exactly, but I have uh, subdivided this entire curve into uh, certain points. So let's say if I'm saying this is my curve, I'm saying I'm standing at A and I'm at B, then I would do some subdivisions. So I'm doing some subdivisions. Are you getting my point? These are some complex numbers. And what would be the most perfect division? कि ये सारे पॉइंट्स बिल्कुल छोटे 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 होके बिल्कुल पास पास आ जाए. आर यू गेटिंग माय पॉइंट? मतलब क्या करना है हमको? व्हाट वी हैव टू डू, वी आर जस्ट ट्राइंग टू, वैसे समझो, वी आर जस्ट ट्राइंग टू सबडिवाइड द कर्व सी, वी आर ट्राइंग टू सबडिवाइड द कर्व सी by you can say selecting some intermediate points, intermediate points. And what those points are? Let's say z0 is A, then z1, then z2, z3 dash 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 zn equals to b. Are you getting my point? And what is contour integral? देखो होता क्या है अब मैथ्स में, क्या है, what is interest? एक एनालॉगस स्ट्रक्चर बनाने का इंटरेस्ट है. एनालॉगस स्ट्रक्चर इंटीग्रेशन में क्या करते थे वैसे ही करेंगे यहाँ पर. what will we do? हम लोग इसके बीच में कोई वैल्यू पकड़ेंगे फंक्शन की. लेट्स से फंक्शन की वैल्यू है f zeta 1 हियर. इसके बीच में कोई वैल्यू पकड़ेंगे, इसके बीच में एक और वैल्यू पकड़ेंगे f zeta 2. तो मैथ्स में वी टेक मैक्सिमा, मिनिमा, देन देयर इज अपर इंटीग्रल, लोअर इंटीग्रल, वो सब भूल जाओ. जस्ट अंडरस्टैंड कि अगर ये लिमिट वैल्यू जो है, अगर ये दोनों के बीच के डिस्टेंस छोटा करते जाए, बहुत छोटा करते जाए, बहुत छोटा करते जाए, तो इवेंचुअली यहाँ पर एक कोई वैल्यू पिक कर ली, एक कोई भी वैल्यू पिक कर ली, ठीक है, फंक्शन की कोई भी वैल्यू पिक कर दी. इस तरीके की एक स्ट्रक्चर को डिफाइन किया. दिस स्ट्रक्चर इज सम्स. यहाँ पे मैंने क्या किया, एफ जीटा, आई वुड से लेट्स से आई, एंड देयर इज डेल्टा जेड आई. अभी एक मिनट डरो मत, मैं बता रहा हूँ ये क्या हो रहा है. सो मैं क्या कर रहा हूँ, व्हाट एम आई डूइंग इज, देखो इस पूरे क्या कह सकते हैं, दिख रहा है ये पूरा सब, ये सारे सबको क्या किया मैंने, पहले तो आई हैव डिवाइडेड इनटू using some intermediate points into I've subdivided the curve C. Is it fine? And what am I doing? I'm trying to evaluate this zi, then you have zi plus 1. तो zi plus 1 minus zi किया और इसको मल्टीप्लाई किससे कर दिया, इसके बीच में कोई पॉइंट पकड़ा, उस पर फंक्शन की वैल्यू से. ठीक है, इन दोनों के, इसको मैंने बोला डेल्टा zi plus 1 माइनस zi, इसको मैंने बोला डेल्टा zi. इस पूरे सब इंटरवल के अंदर मैंने एक पॉइंट पकड़ा, एफ जीटा है, ठीक है, और इस तरीके की चीज को मल्टीप्लाई करती है. या तो ऐसा कुछ देखा हुआ है क्या? ठीक है, या तो इंटीग्रेशन में ऐसे कुछ करते हैं. व्हाट वी डू इन इंटीग्रेशन, सिंगल वेरिएबल में, अगर मुझे ये नहीं पता चल रहा है कि मेरा फंक्शन का एरिया क्या है, व्हाट वुड आई डू, आई वुड डिवाइड इट इनटू many 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 partitions. And what would I do, I would take any of these sub you can say interval, and I would say what is the value of the function in this particular sub interval. In mathematics, precisely we take minimum and maximum, and that would give you a lower integral and upper integral. If it is in the sum form, it will give me a lower sum or upper sum. So don't get there. But in general, what you do in definite integral, you simply subdivide your interval. These subdivisions are called as partitions there. You take a value of function between any of these subinterval. Let's say these are your subintervals. ठीक है, मान लेते हैं ये सब इंटरवल है, और आप क्या करते हैं, टेक एनी वैल्यू बिटवीन दिस, you just take this value, you simply take f xi, you multiply with delta xi, and you sum it all over. If delta xi tends to 0, then this particular sum converts to an integral. Okay. Similarly, if I say my delta z tends to 0, or if I'm not properly dividing it, I would say that let delta zi tends to 0. Delta zi tends to 0 कब? जब ये subdivisions tends to infinity, so if I'm saying these subdivisions tends to infinity, even the biggest of the subdivision also tend to zero. Even the biggest of the subdivision also tend to zero if I'm not uniform. So even if the biggest of the subdivision tends to zero, this particular limit f zeta I, delta zeta I, where delta zeta I tends to zero, would eventually become some integral. So this will transform into some integral. Okay, so this is a contour integral. So contour integral, यहाँ पर कोई भी definite integral type नहीं है. However, the structure is analogous. Structurally it is analogous, but otherwise it does not represent some area. बस ये समझो कोई आर्क लिया, उसको आपने सब डिवाइड किया इंटरवल्स में. इन सब इंटरवल्स के सब डिविजन्स, सब इंटरवल्स जो मिल रहे हैं, डेल्टा जेड दिख रहे हैं, सब इंटरवल्स टक 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 टक, ये सब इंटरवल्स दिख रहे हैं. इन डेल्टा जी को आपने किससे मल्टीप्लाई किया? फंक्शन की वैल्यू बिटवीन दीज सब इंटरवल्स. अब तुम कहोगे यार यहाँ तो बहुत सारी वैल्यूज है फंक्शन की, तो मैं क्या कह रहा हूँ, जस्ट ट्राई टू टेन डेल्टा जी टेंस टू जीरो. इफ डेल्टा जी टेंस टू जीरो, this will become very close. So now you can actually find that almost the function is constant here. Almost it is constant. So what I would do, f zeta I into delta zeta I, this particular thing is called as some sums. And when I tend n towards infinity, what n tends to infinity, matlab, now I'm very close. These you can say partitions or subdivisions are very close to each other. This particular sum would turn into an integral. And this integral is called as the contour integral from A to B. I hope it is clear.
सर फंक्शन में n कहाँ पे है?
हाँ बेटा, फंक्शन में n कहाँ पे है? मैं नहीं समझा.
जो हमने समेशन n किया है वो n.
अच्छा, n सॉरी, तो n क्या है? n यहाँ पर zn पे पहुंचोगे तो b आ जाएगा बेसिकली. बेसिकली क्या बता रहा है, तुम्हारा क्या कह सकते हैं, ये जीटा कहाँ से आ गया इसमें? अच्छा, फंक्शन की वैल्यू एट सम पॉइंट ना. हाँ, तो जीटा एन क्या बता रहा है? जीटा एन, तुम एन मतलब, देखो मेरी बात वापस समझो, मैं क्या समझाने की कोशिश कर रहा हूँ. पहली चीज समझो, इसका कोई लेना देना तुम्हारे डिफरेंट इंटीग्रल से नहीं है, हालांकि स्ट्रक्चरली सिमिलरिटी है. ये समझो, इट
अच्छा सर
रिप्रेजेंट,
समझ गया समझ गया सर समझ गया.
देखो
i to
ये,
n आपने इंटरवल्स लिए हुए हैं बहुत सारे.
z इक्वल टू जीरो पे a था, z इक्वल टू n है b, और इसके बीच में हमने क्या किया, वी ट्राई टू क्रिएट सम डिविजन्स, ओके, फॉर n minus 1 intermediate points. What is the prescription? I'm saying this S is given by summation f zeta I into delta zeta I. So this zeta I is nothing but some point between these subintervals, some point between these subintervals. So let's say this is my zeta, no, sorry, this is my zeta I between sub intervals zeta zi plus 1 and yeah, here it is zi. So zi comma zi plus 1 के बीच में कोई एक पॉइंट पकड़ा zeta I, वहां पे फंक्शन की वैल्यू निकाली and multiplied with the length of the subinterval. So if I multiply with the length of the subinterval into f zeta I, this is some sum. ये कोई sum है, ठीक है. इस sum अब क्या करना है? What I would do is I'll take zeta, I'll take these जो मैंने अभी अभी subdivisions किए हैं, I would take them in infinite number of amount. तो होगा क्या? These will come very close. These will come very close. When they come very close, this particular sum would turn into an integration. Okay, and this integration is called as contour integration. ये चीज समझने की कोशिश करो. Further, you will see that this contour integration converts into two different integrals. Let us see how. So if my function fz is some u plus iota v, then, and dz you already know that z is equal to x plus iota y. So you can clearly see that this would be integration u plus iota v into dx plus iota dw, and you just integrate it all over again. So you'll get u dx, you'll get minus v dy, plus you'll get iota integration, I think v dx, and you'll get u dy. So clearly you can see that your contour integration f z dz transforms into two definite integrals, and these two definite real integrals. There is an iota here. I'm not saying that it is not that way, but these two are two definite, you can say, real integrals. Are you getting my point? अल्पना को समझ में आ रहा है? बेटा नहीं भी समझ में आ रहा है तो अंडरस्टैंड कि ये कोई स्ट्रक्चर है एफ जेड डी जेड, इसका कोई रेलेवेंस एफ एक्स डी एक्स से नहीं है. एफ एक्स डी एक्स वहां पे एरिया रिप्रेजेंट करता था, यहाँ कुछ एरिया रिप्रेजेंटेशन नहीं है, बस ये समझो ये कर्व पे इंटीग्रेशन. दिस इज समटाइम्स कॉल्ड एज लाइन इंटीग्रल्स. दीस आर कॉल्ड एज लाइन इंटीग्रल्स आल्सो इन, मतलब एनालॉगस टू वन वेरिएबल में. ठीक है, जैसे फॉर एग्जांपल जस्ट ट्राई टू फाइंड मी एन इंटीग्रेशन. मैं तुमसे एक क्वेश्चन पूछता हूँ. ट्राई टू इंटीग्रेट आई थिंक चलो ये करो जेड डी जेड अलोंग।
सर एफ जीटा,
हाँ बेटा,
सर एफ जीटा इज अ कॉम्प्लेक्स फंक्शन ना?
एफ जीटा इज अ कॉम्प्लेक्स फंक्शन।
तो ये जो कर्व है ये तो फिर 3 डायमेंशन में होगा।
मैं नहीं समझा। यस यस यस, हाँ हाँ बिल्कुल। सो बेसिकली कर्व 3 डायमेंशन में ही जाएगा। ठीक है, कर्व तो
तो
ना ना, मेरी बात समझो, कर्व कहीं, कर्व कुछ भी हो सकता है, कर्व एक स्ट्रेट लाइन भी हो सकती है, आई हैव नो इश्यूज अबाउट इट। फंक्शन जो होगा वो 3 डायमेंशन में चला जाएगा। फंक्शन विल गो इनटू 3 डायमेंशंस। फंक्शन को नहीं रिप्रेजेंट कर रहा हूँ, यही मैं तुम्हें समझा रहा थी देर से। यहाँ पर क्या होता था, एफ एक्स डी एक्स होता था, तो यहाँ तुम फंक्शन ड्रॉ करते थे। यहाँ पे, यहाँ मैं फंक्शन ड्रॉ नहीं कर रहा हूँ, आई एम जस्ट सेइंग आपने क्या किया, आपने एक कोई कर्व लिया सी, ठीक है, लेट्स से मैंने स्ट्रेट लाइन, ओके, इस स्ट्रेट लाइन के सारे पॉइंट्स के लिए फंक्शन की क्या वैल्यू, फंक्शन अलग से डिफाइन कर दो, लेट्स से एफ जेड इज इक्वल टू जेड। और फिर
ओके 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 ओके।
यही मैं समझा रहा हूँ, यहीं पे कंफ्यूजन आता है, दिस इज नॉट अ डेफिनेट इंटीग्रल। ये डेफिनेट इंटीग्रल नहीं है। बस यहाँ पर क्या करते थे, पार्टीशन से डिवाइड करते थे, उस इस समेशन को तुम, रीमन सम्स को क्या कहते थे, इंटीग्रेशन कहते थे, एज डेल्टा एक्स आई टेंड्स टू जीरो। यहाँ पर क्या हो रहा है, तुम एक कॉन्टोर ले रहे हो सी, आपने कॉन्टोर को सब डिवाइड किया है और एक फंक्शन सिलेक्ट किया, लेट्स से एफ जी इज इक्वल टू सम जी। अब तुम कह रहे हो इसके
ओके
बीच में 1,2 के बीच में फंक्शन क्या हो सकता है ना, उसकी वैल्यू ली इनटू सब इंटरवल, और ऐसे सब इंटरवल्स को इन्फिनिटली लार्ज लोगे तो डेल्टा जी टेंस टू जीरो हो जाएगा, और ये जो सम होगा इट विल बी द कॉन्टोर इंटीग्रेशन ऑफ फंक्शन ओवर दिस कॉन्टोर, या फिर आर्क इंटीग्रेशन, यू कैन से लाइन इंटीग्रल ऑफ दिस फंक्शन अलोंग दिस कर्व। देखो एग्जांपल से समझते हैं, लेट्स से आई एम
हाँ
सेइंग,
जी सर समझ गया। यस
है
सर।
ना, लेट्स से माय फंक्शन इज z and I'm supposed to integrate this z along the line, along a straight line, along a straight line, let's say easier करने के लिए, joining the points 0 to 1 plus iota। ठीक है, मान लेते हैं इसको इंटीग्रेट करना है, तो अब क्या इसमें मैं फंक्शन का ग्राफ नहीं बना, बिकॉज फंक्शन का ग्राफ गो इन 3 डायमेंशन। आई एम नॉट सेइंग दैट, आई एम सेइंग कि ये जो z है इसकी अलग अलग वैल्यूज होंगी। मतलब अगर तुम थोड़ा सोचो, अच्छा पहले अपन एक बार आर्क बनाते हैं, व्हाट विल बी आर्क, लाइन ज्वाइनिंग 0 से लेकर 1 प्लस आयोटा, तो 1 प्लस आयोटा क्या होता है, 1,1 होता है, ठीक है, और ये हो गया तुम्हारा 0,0। यस और नो? ठीक है, अब बोला जा रहा है इंटीग्रेट जेड डी जेड। अब देखो जेड तो तुम्हारा फंक्शन हुआ, सो एफ जी की जगह क्या आ गया तुम्हारा, सिंपली जेड। व्हाट इज डी जेड? तो देखते हैं इस पर्टिकुलर लाइन के ऊपर एक्स कॉमा वाई को कैसे रिप्रेजेंट कर सकते हो, यू कैन रिप्रेजेंट एज टी कॉमा टी, एंड हियर टी इज इक्वल टू जीरो, हियर टी इज इक्वल टू 1। Okay, so integration z dz is nothing but it is integration x plus iota y into dx plus, I think iota dy मानते हो, z dz की जगह लिख दूं, and x and y can be represented by suitably by a parameter t, so I will write it as 1 plus iota t into I think dt plus iota dt। yes or no? और इस पूरे पॉइंट, इस पूरे क्या कह सकते हैं लाइन के अंदर वी आर मूविंग फ्रॉम टी इक्वल टू जीरो से लेकर टी इक्वल टू आई थिंक 1। सो आई एम मूविंग फ्रॉम टी इक्वल टू जीरो, सो टी इक्वल टू, सो इवेंचुअली व्हाट इट विल बिकम 1 प्लस आयोटा हियर, यहां से 1 प्लस आयोटा कॉमन ले तो 1 प्लस आयोटा बाहर, दिस विल बी टी प्लस टी डी टी इंटीग्रेशन फ्रॉम 0 टू 1, एंड 1 प्लस आयोटा का स्क्वायर क्या आएगा, 1 प्लस आयोटा का स्क्वायर माइनस 1 प्लस 2 आयोटा into t square upon 2. So this will give you 1 over 2. This will get cancelled and this will give you iota. So the contour integration, or you can say your, I would say a line integral of function fz is equal to z along the line, along the straight line joining point 0, 0 to 1, 1 would be in iota. Are you getting my point? ये चीज समझ में आई, ऊपर से चली गई? ये चीज समझ में आई? अब नेक्स्ट लेक्चर में अपन पढ़ते हैं, एक लेक्चर और है, राइट? अभी आगे लाइट्स, सो आई विल टेक वन मोर लेक्चर एंड फिनिश इट ऑफ। आर यू गेटिंग माय पॉइंट यहाँ तक? कोई तो कुछ बोल दो, कल्पना को समझ में आ रहा है?